So, what is binary arithmetic? So, binary arithmetic is an essential part of all the digital computers and many other digital systems. And also, the binary arithmetic is a system of mathematics that operates with only two digital systems and computing as computers utilizing binary code to represent and manipulate data. So, in binary arithmetic, there's an mathematical operations to perform, such as the binary addition, subtraction, multiplication, and division.
The first operation is binary addition. In binary addition, it has a rule. For the case 1, we have a numerator 0 plus the denominator is 0, then the sum is 0. The carry is 0. For the case 2, we have numerator 0 plus the denominator is 1, then the sum is 1. The carry is 0. For the case 3, we have numerator 1, the denominator is 0, then the sum is 1. The carry is 0. For the fourth case, we have numerator 1 plus the denominator is 1, the sum is 0, the carry is 1. It's because 1 plus 1 equals 10, then the 0 is automatically the sum and the 1 is the carry. Let me give you an example for binary addition. 1, 0, 1, 0 plus 1, 1, 0, 1. 0 plus 1 equals to 1. 1 plus 0 equals to 1. 0 plus 1 equals to 1. Then 1 plus 1 equals to 10. 0 and 1. To check the binary, 1, 2, 4, 8. 8 plus 2 is 10. 8 plus 4, 12 plus 1, 13. 10 plus 13 equals 23. So, 1 plus 2 is 3, plus 4 is 7, and the 0 is not counted, proceed to 16. Then add it.
So we're done to binary addition. So let's proceed to the second operation, which is the binary subtraction. So the binary subtraction is, its function is subtract and borrow. Then here are the cases, 4 cases of binary subtraction. First case of binary subtraction is if 0 is minus 0, the result will always be 0. Then if 1 minus 0, the result will be 1. Then 1 minus 1, if 1 minus 1, the result will be always 0. So, in the case 4, 0 minus 1 is cannot be subtracted because this is a negative operation. So, this is why we need to borrow. So, here an example, example of binary subtraction. So here, as what I said earlier is 0 minus 0 is always 0. Then 1 minus 0 is 1. Then 0 minus 1 is you need to borrow to the next digit. So this will be
addition, which is the 1, 2, 4, 8, 16, 32, and also 64. These are the binary computation. So 2 plus 8 is equals to 10. So 10 plus 16 is equal to 26. So this is 26. Then 4 plus 8 is equal to 12. So let's proceed to the multiplication process. First, 0 times 0 is equal to 0. 0 times 1, 0 times 0, 0 times 1, then 0 times 1 again, 0 times 0, and 0 times 0 is equal to 0. Because as I said earlier, that if any number multiply into 0 or 0 multiply into any number, well, the answer is 0. Next is same process also to first multiplication, which is also the 0. So next is the 1. So 1 times 0 is equal to 0. Because I just said earlier, any kind of number multiplied to 0 and 0 multiplied to any kind of number, the answer is only 0. Plus 1 times 1 is equal to 1. So 1 times 0 is equal to 0. Then 1 times 1 is equal to 1. Then 1 times 1 again is equal to 1. And 1 times 0, 1 times 0 is equal to 0. Now, lastly is also the number 1. Because if we multiply it, well, the answer is all 0. So this number is the last one to multiply. So 1 times 0 is equal to 0. Then 1 times 1 is equal to 1. 1 times 0 is equal to 0 again. 1 times 1 is equal to 1. Then 1 times 1 is equal to 1. Then 1 times 0 and 1 times 0 is equal to 0. Now let's add the answer. Bring down the 0. Bring down the 0. Because if we multiply it, there is no other number. Because only 0. Again, bring down the 0. So 0, 0, 1, 0, bring down the 1. 0, 0, 0, 1, bring down 1. 0, 0, 1, 0, bring down 1. Then 0 plus 0 equals to 0. 1 plus 1 is equal to 10. Bring down 1, then carry the 1. 1 plus 0 is equal to 1. Plus 0 is equal. Bring down the 0 and then carry 1. So 1 plus 0 is equal to 1. Plus 0 is equal to 1. Plus 1 is equal to 10. Again, bring down the 0, carry 1. 1 plus 0 plus 0 is equal to 1. Then bring down the 0. So the answer is 0, 0, 0, 1, 1, 1, 0, 0, 1, 0. Now, let's compute it about the binary computation, which is the first number proceed to 1, next 2, 4, 8, 16, 32,
32.
64, 128, and also 256. Now, 256 plus 32 is equal to 288. So 288 plus 16 is equal to 304. So 304 plus 8 is equal to 312. So the answer is 312.
So let's have another example for
equals 0. Then 1 times 1 equals 1. 1 times 1 is 1. Times 0 is 0. Then 0 times 1 is 0. 0 times 1 is 0. 1 times 0 is 0. Then 1 times 1 is 1. 1 times 1 is 1. 0, 1, and then 1, 1. Bring down 1. So let's do this. 1, 2. So 16 plus 8 is 24. 24 plus 4 is 28, and 28 plus 2 is 30. So the answer is 30.
Okay, so since we're done to binary addition, binary subtraction, and binary multiplication, we must proceed to binary division. So binary division is similar to decimal division, or it is called a long division procedure. So in binary division, we have a rules. From case 1, a dividend of 0 is divided to divisor of 0, then the quotient will be 0. Then from case 2, if we have a dividend of 0 divided into divisor 1, the quotient is also 0. Then the case 3, if we have a dividend of 1 and divided to a divisor of 0, the answer will be infinite. Then in fourth case, if the dividend is 1 and then divided into our divisor 1, the quotient will be 1. So let's have an example. Suppose we have a dividend of 1, 0, 1, 0, 1, 0 divided into our divisor 1, 1, 0. So okay, first thing to do, we need to get the quotient. So we must first, this first digit, where is the 1? Is 1 is greater or equal to 1, 1, 0? No. So the answer will be 0. Then let's proceed to 1 and 0. Is 1, 0 is greater than or equal to 1, 1, 0? No. So next is 1, 0, 1. So 1, 0, 1 is greater than or equals to 1, 1, 0? No also. So we have 1, 0, 1, 0. So 1, 0 and 1, 0 is greater than or equal to 1, 1, 0? Yes. So let's put 1 in here. So 1 multiplied by 1, 1, 0 is equals to 1, 1, 0. Then we must to subtract it. So 0 minus 0 is 0. Then 1 minus 1 is 0. Then since we have a 0 here, we must borrow to the next digit. So 0 will be 2. Then 1 will be 0. 2 minus 1 is equals to 1. So bring down 1. So we have 1, 0, 0, 1. Is 1, 0, 0, 1 is greater than or equal to 1, 1, 0? Yes. So put another 1. 1 times 1, 1, 0 is equals to 1, 1, 0. Then subtract. So 1 minus 0 is 1. Then we have a 0, so we must borrow to other digit. So this 0 borrow to other digit, then this 1 will be 0, and this 0 will be 1, and this 0 will be 2. So 2 minus 1
equals to 0, right? So, next is bring down the 0. Is 110 is greater than or equals to 110? Yes. So, put 1. 1 times 110 is 110. Then subtract. Then the answer will be 0. To check if our answer is correct, let's convert this binary into decimal. So we have our dividends 1, 0, 1, 0, and 1, 0. The decimal of it is, since in binary computation, we have 1, 2, 4, 8, 16, and 32. So 32 plus 8 is 40. Plus 2 is 42. And our quotient is 1, 1, 1. 1 plus 2 is 3, plus 4 is 7. And our divisor is 1, 1, 0. So 2 plus 4 is 6. 6. To check if our answer is correct, let's divide our dividend 42 divide our quotient 7. Our quotient 7. So 42 divide 7 is 6. 6 times 7 is 42. And 42 minus 42 is 0. So, our